All right. Hello, everybody, and welcome to our final live stream of our CCNA study sessions. My name is Jeremy Chara, and I am probably the most frazzled I've been as I've started one of these because you would think that when you see all of these people do live streams on YouTube and you're like, oh, they bring somebody else on. That must be easy. It's not. It actually turns out to be a lot more than what I thought it was. But sitting right to the right of me should be, if everything is working well, Keith Barker in all its glory. Keith, say hello.
Hey, it's great to be here, Jeremy. Thanks for inviting me on your stream. I'm having a good time already.
Good. Well, as many of you know, I have been doing, this is now probably the 20th CCNA study session live stream that I've done. Started off on Twitch and going that direction, and then ended up in the world of, and actually let me move my screens around. There we go. Ended up in the world of YouTube Live. Now, I want to make sure that this is coming through okay. If you guys can hear us, can you say something in the chat? That would be helpful. Looks like we're hanging. Okay. The YouTube stream is spinning, and I'm not seeing anything. Keith, are you seeing it on your side?
I am playing back the video on another window, actually another browser, and it says an error has occurred for the stream itself.
Right.
It's not playing. It says it's live, but it's not moving.
Okay, well that's not working well then. Error has occurred. Yeah, we ended up with an error. So Keith, my friend, as soon as you clicked on whatever screen you clicked on, your video froze in Skype, and it did the little shrink back down again.
Oh no! You want me to call you back?
Yeah, let's do it.
Here's what I think we might want to do, Jeremy.
Yeah.
Let's forget Skype, do your thing, and let them know I'm in the chats, and I will just stay here the whole stream, and I will just chat away like a man.
All right,
How about that?
Sounds good. I'll try that.
All right.
Hey, I see myself. This is a good sign. Can you guys see me? Testing 1 2. Testing 1 2 3 4. Hello, testing 1 2. Can you guys see me? I'm thinking I'm live, but maybe not. I keep seeing pauses and testing 1 2 3. All right. Someone just said they can see me. All right, good. You're hearing me say testing 1 2. I've got Keith on the chat. Unfortunately, we had to make some last minute adjustments, and the dual video stream ended up not working. Hang on. Give me just a second. I need to pop this out. There we go. All right. That was the most miserable fail that that I think I've had on live streaming thus far. All right. Nonetheless, we had Keith Barker here. I don't know if it's my computer, our connection, or something in the middle, but as soon as we went live, everything literally froze and died. But now I'm here with you, Keith, which is like, I wanted Keith to be here with me, but nonetheless, I'm here with you. Keith is in the chat, and he will be chatting questions to you as we go. So that's how we'll have to play it. Unfortunately, sorry. When you go live stream, you never know. Anything can happen. We'll just have to go with Keith in spirit. All right, good. So, reset. I have been doing these sessions for probably the 20th session or so on CCNA study sessions. And this is it. This will be the last one. Now, I've been posting them all to YouTube so people can watch them. I'm doing everything that I can to try and help those that are getting their CCNA or trying to get their CCNA before the date. But then I'm figuring these are all things that are valid for the new CCNA as well. So this should help people forevermore, and we'll go with that. So that being said, I've wasted enough time with figuring out live streaming starts. So let's dive right in. If you haven't already, I'm gonna chat it one more time. Join the game. AHA Slides, and you've got the little URL right there. That'll let you collect points. The prize is a grand wooden spoon, which I saw in some of the chat. Maybe a fabled wooden spoon, but nonetheless, it's something to aim for, something to shoot for that is free. So that being said, let's do this. I'm gonna flip over here to All right. I just learned that my microphone was off during some of the last section. So hang on one second. I have something to fix. Just a moment. Good. Now you should be able to hear me, right? My head's cut off, but that's all right. We're improvising as we go. All right. So what protocol allows for central management of wireless access points, multiple wireless access points? So grab my pen real quick. When you're looking at multiple wireless access points, WPA and WEP, these two right, let me grab the color, and right here are going to be security protocols. Those are used for encryption and securing. Now, WEP being one of the first and least secure wireless encryption protocols that exist. WPA, actually WPA2, known as WPA-ENT Enterprise, that's the radius form of it, is the modern day one that we use. Ad hoc is not. That's typically, standalone wireless access points. So this guy, the lightweight access point protocol, is got to be the right answer. Let's go ahead and flip over right here, and we are correct. So answer is D on that one. Good. let's hit the next question. Okay, looks like sound is there. I'm literally building this bridge as we're walking on it. So head's not cut off. That's good. Thanks, guys. All right, so next question. Question number 2. You have been alerted that TCP leaving an interface has been reduced to near zero, TCP traffic, while UDP traffic is steadily increasing at the same time. What is this behavior and what causes it? Give that a whirl. All right, let's bring it back right here. So we've got TCP traffic leaving interface, reducing down to near nothing. UDP traffic is steadily increasing at the same time on monitoring. So let's look at these answers and see what we got. So first and foremost, it says jitter caused by lack of quality of service. Okay, so let's think about that. Jitter is actually a delay variation. So a jitter happens when you've got, let's say packet 1 goes from here to here, it takes 100 milliseconds. Packet 2 goes from here to here, it takes 120 milliseconds. That's technically 20 milliseconds of jitter, meaning there's a 20 millisecond difference between the time it took to send packet 1 and the time it took to send packet 2. That's really bad for voice over IP, but has nothing to do with this question. So we know it's not answer A. Latency caused by the MTU. Sounds like something that could be right. Latency. Okay, latency is how long it takes to get something from point A to point B. Caused by the MTU, that's how big, maximum transmission unit, how big the packet is. Sounds right, but has nothing to do with anything. I mean, it sounds technical. How about that? It doesn't sound right. So windowing. Okay, now we're on to something. Windowing caused by network congestion. So TCP windowing is how much data is sent at one time. So it could send a whole bunch of data. It'll start small, a small amount of data, and then as it sees bandwidth, it'll increase. Well, if there's drops, you'll see the window size shrink down quite a bit, which means the bandwidth that TCP uses could drop down. Now, what I'm seeing here is it's saying TCP traffic is reduced to near zero while UDP is steadily increasing at the same time. So it might be C, windowing, but I don't know why TCP would suddenly drop to nothing and UDP would keep climbing. I would think there would be some kind of mix if that was the case. So let's look at D. Starvation caused by improper configuration of quality of service queues. Guys, I'm thinking that's the one. And the reason I say that is because that's exactly what would happen if you had quality. Now, it could be C, but I would say the best answer, when they say choose the best answer, is D. So let's go with that. Bingo, we got it. So it's starvation. I'm curious how many people. Let me take a. Sorry, with all of the technical difficulties, I never had a chance. Isn't this fun? I get to move locations as I'm flipping from small circle to full screen. So let me make sure I didn't miss any questions from some of you guys as we've been going through. So first off, hi to everybody. I saw there's a bunch of people saying hello. Good to see you. Good. I think everybody's on the same page. Hello, Anthony. Good. Okay, so we're good. We're on the right path. So if you have questions, feel free to chat them in. And between each question, I usually stop and look and just see if there are any. By the way, just so you can see where I'm looking, here is my screen that I'm writing on with the quiz questions. Over there is where I can see all of the questions up on my wall. And so yeah. That being said, let's jump back here. So question number 3. You need to ensure your company's security awareness training includes examples of social engineering attacks. Which of the following is an example of a social engineering attack? Keith Barker's on the chat. This sounds like something that would be in his world. Why don't you give that a whirl right now? Or I'll bring this back while you guys are thinking about it, if some of you are still answering. So social engineering attack is just like it sounds, social, something that involves communication. It could be something like calling in and being like, hey, this is IT doing an audit. We need to reset your password. Can you give me your current password so that we can reset that for you? Some people would fall for something like that. It's known as a social engineering attack. So looking at this list, an email hoax feels like the most likely, but looking at the other, Trojan horse, that's more of a virus or malware. A backdoor, again, a backdoor is a backdoor. It's a hole open in a system, a security hole. Has nothing to do with social engineering. A logic bomb. Sounds dangerous, but no, has nothing to do with social engineering. So email hoax is what we have. So good if you got that one. A couple people on looking at the queue. Yes. By the way, Thrill Seeker has an amazing point. There are actually people out there now that make a full-time income just trying to scam the scammer, like they're calling back some of the phishing. But some of them are really good. Like emails that come in that look like they're coming from company CCOs, and these are actually called, they're a different form of social engineering attack where people are actually researching companies, figuring out who's who, determining which email addresses to spoof. They're getting really good. So yes, absolutely. Social engineering attacks are rough. Good. So let's hit the next question. Question number 4. Which Cisco iOS command is used to view the Vlan trunking protocol statistics information? Give it a go. All right, good. I actually have a lab spinning up in the background. So the new CCNA at CBT Nuggets has labs included. I was going to show this to you, but it didn't have time to boot. So the command used to view VLAN trunking protocol information. We've got show VTP statistics, domain, counters, and status. The tricky part is remembering whether it's statistics or status. because I just type in ST and hit the tab key, and I'm trying to visualize what pops up there. I want to say it's show statistics. Counters. I was way off. Show VTP counters. Hang on. Show VTP stat. Okay. Hang on. Use to show statistics information. That threw me. So VTP. What I usually do when I'm doing, I usually do the show VTP. I think it's status D. Now that I'm looking at, I've got the lab spinning up on the side. So that's pretty much the only command that I type in to verify whether domain names are mismatched, whether VLAN information is coming in, if the database revision is incrementing and correct. Honestly, I don't use VTP counters on a regular basis, but there it is. That's what the command looks like, where it's showing how many packets are sent and received on there. So I would have gotten that one wrong. I would have gone for show VTP statistics or status. I don't know which one, because that's the one I always type. All right, next question. Question 5. Which of the following IPv6 commands is used to define a static host to name... let's try that again. Used to define a static host name to address mapping in the host name cache. Give it a whirl. All right, coming back. I don't know why. I had to show you when I brought it over. This is the command I always show VTP status. I always type in ST and hit tab. That's the relevant one. Nobody types in show VTP counters, just for the record. All right. So which of the IPv6 commands? So A is probably the command that trips up a lot of people, because this command is what you type in to get IPv6 running on your device. Without that, virtually nothing with IPv6 works outside of maybe assigning an address and doing a ping. However, in this case, we're setting up a DNS mapping, a static hostname to address mapping, which has got to be D. That's going to be IPv6 host. And yes, that is where we go in and make a hostname to IP mapping, which in the IPv6 world definitely needed, because those addresses are mammoth. Good. So I'm seeing some people reporting the quality of service is having issues, jitters. I hope this live stream is a bit problematic, but I'm hoping that it's going okay for you now. So any other questions? So bad at IPv6. By the way, IPv6. Just here, I'll flip back to this for a second. Yes. So IPv6 is one of those things that once you just saturate in it for a little while, it's one of those things that will just click for you. For the longest time, even myself, I would teach IPv6. I'd go through it and I'd just be like, I don't like it. But it's just because I hadn't given myself enough time to literally just kind of soak in it. Best thing I can tell you is do labs where you assign IP addresses and set up routes again and again and again with IPv6. Assign IPs. Set up routes, assign IPs, just do another lab. And all of a sudden it'll click for you, because you're going to realize this thing is almost exactly the same as IPv4 with all the concepts. It's just dealing with a bigger address. And in the end, using that CIDR notation is actually, it turns out to be pretty easy once you get used to it. Good. So that being said, just soak in it. I saw somebody on the IPv6. All right. So just glancing at the chats as we were going. Sean, my thoughts are with you. Good luck on ICND2. Which of the following topologies are used in wide area networks? All right, this one shouldn't take much time. I'll talk about it while that timer's ticking down. Which of the following are used in wide area networks? So FDDI is an old fiber optic connection type used locally on a device. Sonnet is the one that is everywhere. That is, think of that as your Metro E/WAN technology. So when you think Sonnet, think sonic rings. And literally the way it works is they will trench up, they being carrier. So here's a carrier, right? They will trench up streets around the city and run a ring this way and a ring this way, and typically with different physical facilities that connect to all of their different customers. So you'll have a customer A, let's just say, click, click. They're plugged into the double ring. So if one of these rings go down, they have an alternate connection. So SONET rings are the WAN connection that are here in this list. Token ring, heaven forbid we go back to that. That is an old technology. But that is what we use. That's our modern wide area network. And there are SONET rings, there are SONET connections, there are fiber lines running, hundreds and hundreds and hundreds of miles beneath oceans. That's where everything is moving, just because the bandwidth is virtually limitless there. Good. A couple people chatting in SONET. Good. All right. Next question. Question 7. In the exhibit below, the routers are running Ospf and are set to their default configurations. What would be the effect of configuring a loopback interface on router A with an address of 192.168.1.50? Think about it. Ready? Go. All right, here we go. So first and foremost, so we're here not just to read questions and answer them. I'm here to give you concepts around it. What is the DR? I've got 62 people that are engaged right now. So what is the Ospf designated router? Hang on, let me get my pen here. So when you have multiple switches connected to, or multiple routers running Ospf connected to a switch, a LAN environment like this, one of them will become a designated router. That is the king of the network. And the reason this happened is a lot of times, like for instance, at a carrier, like a service provider, you might have, a whole bunch of switches that are connecting to customers through WAN links and all that kind of stuff. And they all come back and terminate in the LAN. Here's a whole bunch of routers down here, terminating into the LAN of the carrier. Well, if we're running Ospf, we don't want all of these forming full neighbor relationships, because at that point, if something goes down, let's just say this network fails, well, this is going to send an update being like, hey, network down. It's like a fireworks show. All the routers are going to be like, oh man, all the mine. So it just becomes this explosion of communication. Instead, so think of the DR like the manager of the network, right? You have this single point of contact, one throat to choke, if you will. That network goes down. It goes, okay, I'm going to tell my designated router. The designated router looks at it and goes, got it, okay, let me tell everybody else. Stop the fireworks storm, right? Now, that being said, the designated router will be the one that has the highest IP address on that LAN or the highest loopback IP address. So by assigning router A with an address of 192.168.1.50, he then becomes the highest, so he should become the designated router of the network. Now, most of the time, it doesn't matter who becomes. I'll tell you honestly, most network administrators, if you said, who's the DR, they would go, I have no idea. Why do I care? It's just something that happens automatically behind the scenes. But in some network topologies, especially where not everything is connected together fully, it matters. And you'll want to pick which router becomes the designated router. You can see right there, this is the preferred way, right here, Ospf priority, IP Ospf priority, to select the designated router rather than just relying on IP address to break the tie. Good? Good. Nugget love! I see Anthony's comment in there. So, and actually, EJJ is asking a great question. Doesn't the DR change only if the current DR goes down? So unless router B goes down, router A wouldn't become the DR automatically. Technically, you're absolutely right. So once you do that, you're right. What would be the effect? So I guess the best answer isn't there in the list. You would want to clear the OSPF neighbors first, then router A would become the designated router. That's a huge good point on that. All right, good. Next question. You have configured a router as shown in the following output. There's our config. Host on the LAN cannot receive an IP address. What is wrong? Give it a try. I just saw Keith chat in there. This is a great question. This is actually a really great question, and there's so much more that can go on with it. So it says we're looking at a router. Router's configured this way. It says host on the LAN cannot receive an IP address. Okay, so let's look at this. This right here is the DHCP pool. So it says we're handing out IP addresses from the network 10.2.10.0, right? So you got a big clump of addresses. DNS server, that all looks good. Great. We then got our internal interface, Fast Ethernet 0. So here's our router. I'm assuming the internal one. Our external interface right here, which is serial 0/1. And then we've got access list and the NAT configuration so that these hosts can get out and access the internet using that. Challenge here is that we're missing something under the configuration of Fast Ethernet 0/0, and that is an IP address that needs to be configured on that interface. The fact that that's missing means no IP addresses would be handed out. And I think one that would step up this question a notch on the toughness and the real worldness of this whole thing is if you actually had an IP address. IP address, let's just say 10.1.10.1, 255.255.255.0, right? And throw an IP address on there. If it's not in the same subnet as the DHCP pool, the router is smart enough to look at it and go, I'm not handing out those IP addresses. That's the wrong subnet, right? So I think that would be like a +1 for this question if they had that on there. But either way, that is a great question. I'm curious how many of you got that one. It's a really good question. Good. I'm curious, Isabella, do you have the leaderboard up there? Who's leading the group? Up and Up?
Then Tom D.
Up and Up, Tom D, and who's third?
Network Ninja.
Network Ninja. That's our point. I think after every question it shows the leaderboard. So nice job, guys. Oh, Yo-Yo 155. He's up and up. Good job. He's in the lead. Take him down. All right. Next question. Question 9. Your company is located in Charlotte, North Carolina. Management has decided to deploy multiple 802.11a wireless LANs. They got some eBay equipment apparently. You're concerned that there's not enough there are not enough non-overlapping channels to support the number of access points needed to deploy. How many non-overlapping channels are supported in this deployment? Some people rushed for the points and got it wrong. Now, if we were talking, so it's funny because 802.11a, I mean that's a standard that that has not been like we're not deploying. Let's just say we're not deploying that in new network deployments. But that being said, we're talking about the 5 gigahertz spectrum. If you were talking about the 2.4 gigahertz spectrum, which would be 802.11b, right? If we're going with old school, there would only be 3 non-overlapping channels. But and this is the huge advantage of using 802.11a is that you can. I'm delaying on giving you the answer right here. You can with 802.11a. So here's your building, right? You can install a wireless access point right here. Have it on, we'll just call it channel X. Here's a wireless access point, channel Y. Here's a wireless access point, channel Z. Here's the wireless access point, channel A. All these wireless access point. The beauty of 5 gigahertz is you can have all kinds of overlapping signals, which you want in a business to make sure that you don't get dead zones, drops between your wireless access points. And that gives you the flexibility because you have 23 clean channels. And that's not even talking about some of the newer channels, the DFS channels that they've released as of late. But 23 clean channels in the 5 gigahertz spectrum space. So see if anybody got that one correct. Any thoughts on that? It's funny. As YouTube auditing comes in and blocks some of the comments, so I have to prove some of them as it comes through. But yes, question coming in from somebody is this all new CCNA stuff? Yes, the new CCNA and actually the old CCNA. It's both. This is on both the new and the old. The test bank folks actually did a new revision that has both styles of questions in there. So yes, you will end up with questions like this. Although on the real exam, they probably wouldn't say 802.11a. They would have one of the newer standards or just specify 5 gigahertz. Question from Kevin. I want to grab this one while we're here. He's saying, let me read it. So what, I still don't get it fully, but when would you use 2.4 gigahertz over 5 gigahertz or the other way around? That I'm super glad. Oh, wait. I clicked the next question, I think. Don't look at that. Hang on, watch this. Whoop, it's gone. So 2.4 gigahertz. Let me give you the preview. 2.4 gigahertz. The beauty is one, you have range. 2.4 gigahertz is awesome, especially if you're going outdoors, because it's got the farthest range when compared to 5 gigahertz. 5 gigahertz, you have more spectrum. So I'll draw little bullets right here. 2.4 gigahertz has range. 5 gigahertz has spectrum, meaning you can have more wireless access points close together, but also you can have more bandwidth because you've got more frequency space to work with, radio frequency space to work with. The only other thing that I would say advantage-wise is 2.4 gigahertz is very compatible. I'll just put compat. Everything in the world that at least existed at some point on a wireless network will support 2.4 gigahertz. And there's some things, if it's really old or like I've got an old printer or an old something, a lot of times even some of the little, the Wi-Fi like light switches that you buy really cheap off of Amazon, things like that to automate your home. Some of them are 2.4 gigahertz only. So to have full compatibility, you'll do that that both. But the challenge with this whole space is it's saturated, just oversaturated. So sometimes it's, especially if you live in an apartment complex or in a large office building, it's really hard to get a clean signal on 2.4. That's why 5 gigahertz is the future. So that being said, let's get our test back up. Question number 10. Examine the output of the show IP route command below. Foop, which of the following statements are false? All right. I know time is still ticking, so let me talk through some of these while you guys are thinking through the answer. So I'm seeing the show IP route, and by the way, I've often seen it on the real exam where the formatting is messed up too, to where the spacing isn't quite right. Probably when some copy and paste happens, it removes all the tabs or something like that. So you may run into that. So let's look at the first one. It says the route to 192.168.2.0/24 uses the default administrative distance. That's this guy right here. And it's showing this is an OSPF route, administrative distance of 20. OSPF is not an administrative distance of 20 at all. That's external BGP. So nope, that's not the case. The route 30-30-30-30 uses a cost of 21. 30-30-30-30. Nope. So when you're looking at a routing table, this right here is the cost, right? This right here is the administrative distance, right? How believable that route is in a routing table, and then how good is that route on top of it. So in this case, it's saying uses a cost of 21. No, it's in this case it would be administrative distance of 21, cost of 50. So that's not it. Traffic will be load balanced across two routes, 30-30. Hang on, let me clear this up. Two routes to 30-30-30. I'm seeing this right here, and no. So with the formatting, it's kind of hard to see, but this right here is, it looks, I don't know what that is. I would say that's like a messed up output or something, because right here it's saying this is subnetted. There is one subnet. That's it right there. So whatever subnet is it's a /32 subnet right there. That's it. And it's saying I can get there via this or via that, but it's this should be tabbed over here. Traffic will be load balanced across two routes. I would say that one's hard for me to say just because of the way the formatting is done. So I'm gonna put a hold on that and then look at D. The command IP route 192.168.2.0 subnet mask gateway with an administrative distance of 200 will replace the current route to 192.168.2.0. So if I were to look right there, 192.168.2.0. Saying with an administrative distance of 200. No, I would say that's not the case, because that would 200. No, so this would be a higher administrator. So I'm just gonna put high. High administrative distance. With administrative distance, lower is better. For example, a static route has a default administrative distance of 1. So I would say the answer on this guy, best one, I know that the formatting is a little off, but I would say that would be C. Let's check that out. Oh, wait a sec. Did I read that backwards? Will replace. No, it will not replace. Which of the following statements is false? Will replace, well, I read it backwards. I would have missed it. So yeah, that it's correct. This command will not, hang on, let me clear this off. This command will replace, no, it will not replace. Which of the following statements is false? See, this is where it scrambles my own brain oftentimes to read these. Is false, it will replace, no, it will not replace. That's a true statement. So I read the question backward. I was looking for what is true and what is not true. So D, right answer. All right, good, fair. Who's in the lead, Isabella? Up and up. Up and up, still in the lead. All right, next question. Question 11. I don't have a quiz, an AHA slides question for this because we can't really replicate this same interface. So let's just do this one together. Click and drag the network devices from the left to their appropriate descriptions on the right. So we've got switch, router, hub, firewall. All right. Used to connect separate networks and network types. I would say that would be a router. Protects the network from unauthorized access attempts. That would be a firewall. Regenerates the signal when passes through its ports. That sounds like a hub. And then provides a separate connection to each node for a company's internal network. That would be a switch. That's a good CCNT, ICND1. But on the new CCNA, valid because they've merged all those questions into one. Click OK, and then we've got a full explanation. Good. So those are right. All right, next question. Question 12. Testlet. Click on the scenario heading. So, okay. Oh, okay, we can do this. Okay, here we go. So you have just added, here's our exhibit. You have just added a new DHCP client and connected it to the switch connected to R2. Okay. You're able to ping from R2 to the DHCP server. When you start the new client up, what command must be present on R2 to prevent R2 from dropping the packet? Read that through, look at the picture, give it... Thanks, EJJ, for my my music DJ selections. I literally the music that I get is copyright-free music. I have a Soundstripe account, and literally I just look for happy music. I love my playlist. I know it sounds funny, but I literally have non-copyrighted music I'm jamming out as I'm doing all my training. So you've just added a new DHCP client and connected it to the switch that is connected to R2. You're able to ping from R2 to the DHCP server. So, by the way, this is how I think through when I'm taking one of these exams as well. I'll grab a pen, I'll draw it out on paper. So, new DHCP client connected to the switch, connected to R2. So, there it is, right there. It's plugged in, right? You're able to ping from R2 to the DHCP server. So, this guy, wherever the DHCP server is. Hang on. I lost my train of thought. DHCP client connected to the switch, connected to R2. Okay, that's this guy, right? Right? Good. Okay. I see VLANs in this picture. You're able to ping from R2 to the DHCP server, which, I'm looking here. Where's I don't know where the DHCP server is. Okay. When you start the new client up, what command must be present on R2 to prevent R2 from dropping the packet? Okay, so one of two things could be the case here. One is, again, they're not showing where the DHCP server is at. So it could be here, and maybe that's it. Could be here, maybe that's it. But looking at these answers, I'm looking, okay, helper address, that's a big one. It could be that. IP subnet 0, that's a really old command that we used to have to type in to be able to use the first subnet whenever we would do subnetting, and so that's not it. IP route is what we would do to create a static route, and IP domain lookup. So I can tell you what they're looking for here is this guy, but I sure wouldn't have worded the question that way. I'm assuming they want you to look at it and be like, okay, there's multiple VLANs. Maybe that client is on a different VLAN or on a different network. So a helper address, that's where that guy would come in. Yep. That would allow it to relay through R2 to wherever that DHCP server is at. Good. So yeah, this is a tough question. And by the way, when you get to the real exam, there will be some here where it'll be like, well, you're not giving me enough information, but unfortunately, there's nobody to complain to. You just got to do the best with what you've got. So sometimes you just got to be like, okay, I'm assuming this is the best one. All right, next question. And by the way, this will be our last question. I know I had a few more on the AHA slides, but I have to get to my son's baseball game, and I told him 1 hour. That's all I got. All right, so question 13. Which of the following commands help you determine the layer 1 and layer 2 oh, this is easy. Up-down status of a Cisco interface. Just take a few seconds. Take a stab at it. All right. I got flagged for my daughter. She's like, you have time, so I'm gonna go for a few more. So on this one, the up-down status right here, I've got. Let's grab. This will even work on a switch, which I happen to have in this. This, by the way, is our new labs that we have for the new CCNA at CBT Nuggets. Easy for me to type and talk at the same time. There we go. So if I do a show interface or how interface, how about show interface? That will allow me to see the up-down bandwidth. It's actually right here, this TX load, RX load. This will give you the send and receive bandwidth that's coming through that interface. Transmit and receive on a scale of 1 to 255, which had nothing to do with the question. Sorry. The up-down status, this right here, is what I was... I'm telling you, when the live stream just blows up at the beginning, my brain is like, you might as well just wring it out like a towel. So this is the up-down status. Gigabit Ethernet is up. That's physical. Line protocol is up. That's our data link layer. This pretty much tells you is it operational? Is there an interface there? And then this one tells you, is it actually communicating electrical signals? That kind of thing. So that's what we're looking for right there. So answer is C. Good. Okay, got a few more questions for you, and we'll go from there. We'll wrap up after a couple more. All right, next question. What port types are available for Rapid Spanning Tree Protocol, but not available in Spanning Tree Protocol? Choose 2. Bringing it back. I always get these ones wrong. But so I'll tell you, I'm just staring at it. Here's how I would approach it. I know in normal, so why do I get these wrong? First of all, because in the real world, when you're doing show commands and getting the output, which is a lot of times the world I live in, I'm like, oh, I know what that is, but just from a laundry list, it's really hard for me to recall. So I know in spanning tree, how I would approach this question, I know normal spanning tree has a designated port and a root port. So I know it's not those two. A learning port, that's part of the port transitions where it goes from listening to learning to forwarding. So I know learning is not one of those. So that's what would get me whittled down to alternate port and backup port. So again, I usually mix these two up. Alternate port, I think, is where it's the backup port to reach the root bridge. And the backup port is a backup port to get to, it's backup to a designated port. I think that's how we're handling. Let's check it. Good. That's the right answer. Alternate port is an alternate path to the root bridge. Good. But so it's currently, so it's a loop. It's a loop port, but that's how it transitions quicker than old spanning tree is. It's like, I know that one gets to the root bridge, whereas the backup port is an alternate designated port. So again, if you want more on that, and I'll make a plug again. I always say it's a shameless plug, but it's free, so there's really no shame at all. On my YouTube channel, on one of these live streams, I did a complete walkthrough, all the different spanning tree ports, how it would figure out the best way. So head to my YouTube page and check that out. It is really good. Okay, next one. Question 15. We'll do this one and one more after it, and then we'll wrap up. That'll fill out our quiz. Which of the switching process requires a switch to wait for the entire frame to be received before forwarding it to a destination port? This is an old question. Give it a try. Take a few seconds. All right, this is one of those questions that you either know or you don't know. So looking at this now, this is old, as in I'm not even sure if this option's available on Cisco switches anymore. But the switching process that requires a switch to wait for the entire frame, like I was learning this 20 years ago when I got my CCNA. That is store and forward. That's where it receives the whole frame first, figures out where it's, make sure the frame's, FCS sequence looks good, and sends it on its way. It's the slowest form of switching, whereas cut through is the one that just looks at the header and says, oh, I know where it's going, sending it. Fragment free is the one that reads the first 64 bytes, and then decides to forward the frame from there. So store and forward is this one. That's an old question. You that might see that in ICND1, but probably not in today's world. All right, last question. Here we go. Question 16. You've executed the following commands on the switch. Which of the following situations will switch 64? In which of the following situation will 64 create an ether channel? I love my soundtrack. So, I'll turn it down. So somebody asked, what do you do to keep all this information straight in your head? Actually, it's funny. Keith is with us. I remember a conversation I had with him. I said, "How's it going today?" And I can't remember the exact thing he said, but he said something to the effect of, just relearning all the same stuff that I've learned before one more time. And so the truth be, I mean, you can see I've taught CCNA for 20 years, and I'm still like, oh, what were those port states? It's one of those things that there's only so much brain storage, and it will leak out. But obviously, talking about it all the time helps. But that's why oftentimes you become a human dictionary of Cisco stuff. So, looking at this output, look at this. We've got interface range, gigabit Ethernet 2/0, 1 through 2. So that's 2 interfaces bundled together. We've said these are going to be access, which means they're going to be one VLAN only. Not usual for an Ether channel. Usually you'll have it be a trunk, but that's fine. It can be an access port as long as the other side's the same. VLAN 10 is it. So channel group 5 mode auto. This is the key command. This is what makes it an Ether channel, aka lag port, link aggregation. 2 modes. Well, actually 3 modes that you'll want to know. On means there is no negotiation. And that's actually really dangerous because if the other side doesn't get configured correctly, you could cause a loop in the network by having one side on and the other side just not configured right. So you don't want to use on. That's known as manual Ether channel. Usually I'm like, hey, leave the auto configuration off, but this is not one. So auto configuration is the passive mode to where it's like, hey, I'm just going to wait and see if the other side is going to be wanting an Ether channel or not. If it is, then I'll be one. That's fine. If not, then I will just sit here and wait. So if you have both sides, if you've got a switch here and a switch here, and both are set to auto, it will not form an Ether channel. But if one or both sides are set to desirable, answer C right there. If one or both sides are set to desirable, then it will say, I want to be an Ether channel. Auto will flip over, or desirable is obviously a good mix. And that's what I usually do. I'll just do desirable on both sides so I don't miss something. And it will negotiate and form an Ether channel. So let's check the box. Answer C. Is it Isabella? Who is our winner for the day? Up and Up, 1,035 points. Congratulations, Up and Up. Nice job. You're ready, unless you already have your CCNA. Who's our second and third place? Thrill Seeker and No Tourist TCP. Something to that effect. So congratulations. Well done, well done, guys. So this is it. We are on Thursday. I'm assuming I saw some people typing in. They're taking the exam tomorrow. My prayers, my thoughts are with you. Good luck on that, and I hope that you do well. I would normally spend a lot of time answering questions. Wooden Spoon goes to you, Yo-Yo, but I kind of pushed it a little beyond. I've got to run to my son's baseball game. So I actually have a whole set of live streams planned for March, but I'm putting CCNA aside for now, which is actually, it's good. I'll come back to it, more of it later. March is career month. I want to talk, because I've gotten so many questions, I want to talk about how you get a job with this stuff and things that you can do if you have a job to start moving up. Because I think, and I want it to be collaborative. I have so much cool stuff planned. So March, so I'm going to take next week down, get prepped up so I don't blow it up again like I did with Keith. I'm so sorry. Keith Barker hung out the whole time. He was going to be on here with me if you're joining late. And it blew up. But I'm looking for a ton of collaboration when we get there. It'll be fun. So that being said, great to see all of you. Spring Mommy, a lot of the regulars that have been with me for a lot of these live streams. Great to see you. And you guys have a good weekend. I'm off to the baseball field. Take care, guys.